Hello guys, so we are back again, and in this session we are going to continue with the second order and higher order derivative problems, as I told you in the previous lectures. In the last lecture which we did, we covered first order partial differentiation types questions, and there were about 5 questions or 4 questions, I don't remember properly. And they were very easy because first order partial differentiation questions just involve getting the first order partial differentiation and then substituting the values in the proof and a little bit of manipulation. Now let's begin with the second order and higher order derivative, right? So in this session we are going to solve some questions on second order and higher order derivatives. I have already told you what second order and higher order derivative means and what are their specifications. Okay, now let's begin with the question. So the first question which we are going to see is as follows. The question says, if z equals to x squared tan inverse y by x minus y squared tan inverse x by y, prove that dou square z by dou x dou y equal to x square minus y square the whole upon x square plus y square. So we want to find first partial. Now how to read this? It is nothing but partial derivative of y, the partial derivative of z with respect to y first, then partial derivative of z with respect to y, and first you have to find partial derivative of z with respect to y. Okay, and then whatever you get, you have to partially differentiate it with respect to x. Then you will get dou square z by dou x dou y, and these are mixed type of derivatives, as a mixed type of higher order derivatives, as I mentioned you in the first lecture. So we know how to do, but the steps are very important. First you have to write z. Z is what? X squared tan inverse y by x minus y square tan inverse x by y, right? We got our main function. So what we want to do? Partially differentiate z. First we will go with this side. Okay, you have to move from right to the left side. Okay, so first we will partially differentiate with y and then with respect to x. Partially differentiate z with respect to y. What we are getting? Dou z by dou y, which will be nothing but we have to partially differentiate this. This is constant because we are differentiating partially with respect to y. So I will differentiate only this thing. This will be constant. You have to mention all these steps. After this, you will differentiate both of them. So you have to apply the product rule because you are differentiating with respect to y. So y square dou by dou y tan inverse x by y, right? Plus tan inverse x by y dou by dou y square, right? If I differentiate this partially, what I get? 1 by y square by x square, and then by chain rule we have to partially differentiate this y by x, which will be nothing but 1 by x. Now what we are having here is y square. When I partially differentiate this, we have x square by y square, and if you partially differentiate, we have 1 by x by y square. If I partially differentiate this, I have tan inverse x by y. Here I have 2y. What we are getting? This will cancel out. X square plus y square minus, this will multiply with here, and this y will move here, and this y will been already cancelled out, so we are left with this will become plus since minus is already there. After this we'll move on this will be negative 2y tan inverse what, x by y. So we got, this is our first thing. Now this is what, dou z by dou y. Now we want dou square z by dou x dou y, which will nothing but partially, you have to give it 1. Okay, you have to give it 1. Partially differentiate 1 with respect to x, we get, which will be dou square z by dou x dou y, which will be nothing but dou by dou x into dou z by dou y. Now we have to do what, differentiate them. Here you can clearly see, okay, we can also simplify this. We can, okay, this we can we would have simplified it. It will be nothing but x square plus y square into x, right? So but okay, I will write here x square plus y square the whole square, right? Now we will partially differentiate this thing. So first x square plus y square will be as it is, dou by dou x will be this stuff, which is here x square plus y square x, then it will be minus what, this will be outside x square plus y square x, and we will differentiate this thing, dou by dou x, x square plus y square, right? Now in the next step we are going to partially differentiate this thing, and here since minus is there, we'll move it outside, and this will be dou x what, tan inverse x by y. Now let's differentiate and get the answer. If I differentiate it, what I am having here in the denominator is x square plus y square the whole square, right? Here we have x square plus y square. Here we will have, since we are differentiating with this, 2x plus y square, and here what we will have, x square plus y square x we already have. Here we will have 2x, this will become 0. Now this thing will be what, 2y 1 plus x square y square. We will partially differentiate this, which will be nothing but 1 by y. What we are getting finally here, this will become x square, this will become x cube. So we can take x square plus y square common from both of them. Here okay, let's see what we can do. Let's open this and see whether we are getting something we want to find. Okay, let's open this. We are having x square plus y square. Here x square plus y square. Here it is 2x plus y, not y square. We are doing some mistake about. Let's check. 2x plus y square. 2x, fine. X square plus yx. Here we did any mistake. 2y, y square got cancelled. This was what, minus plus y square x. Okay, no, nothing mistake. Now what we are going to do, 2x plus y square as it is. Here if I multiply this, 2 will be this will be x cube plus y square x square, right? If I take, I have to open it, I guess, 2x square. Okay, so let's check what mistake we are doing. X, okay, we are not written x square. If this is x square, then 1x will cancel out, and we will have x square in the top. x cube in the top. So this was the mistake, I guess. Rest of the thing will be what? Here it will be x square plus y square the whole square. It will be this thing. We will apply the chain rule. Here it will be x cube, y square x, then rest will be correct, x cube, and then we can solve. Now the moment I differentiate it, I will be left with 3x square. Here it will be 3x square. Now let's see what mistake, any other mistake which we did. X cube, and this is x cube, and rest of the things are correct. The moment it goes here x, it will become x power 4, and this will be x square. This is nothing but 3x square. Now this is x square plus y square the whole square. This will become what? Y will cancel out, minus 2y square, y square plus x square, right? Minus is already outside. Now we can take x square plus y square from both of them common. Here if I remove x square, I can get x square plus y square. So I will take x square plus y square common. I am left with 3x square plus y square minus 2x square, the whole by x square plus y square the whole square. This one x square will cancel out with this, minus 2y square by x square, which is this thing only. This and this will simplify, giving me finally x square plus y square minus 2y square the whole by y square plus x square. Now if I simplify it further, this will cancel out. We will get x square minus y square the whole by x square plus y square. So this is our required proof which we wanted. Okay, don't do any silly mistake. The questions are very lengthy. If you do any mistake, you will get wrong answer. Now let's move on to the next question. The next question is this: if u equals to e power xyz, prove that dou cube u by dou x dou y dou z equals to 1 plus 3 xyz plus x square y square z square into e power xyz. We have our standard function e power xyz. We will first differentiate it partially with respect to z, then that with respect to y, and then that with respect to x. So partially what? Differentiate u with respect to what? Z. What you will get dou u by dou z will be nothing but, if I partially differentiate this, it will be e power xyz into xy. Simple. We'll call it as 1. Now partially differentiate 1 with respect to y. What do you have? Dou square u by dou y dou z as per the rule, which will be nothing but dou by dou y into dou u by dou z. If I solve it, what we are getting here, chain rule will be applied. First xy will be left here, it will be dou by dou y e xyz, then plus e xyz here, and dou by dou y xy will be partially differentiated. Here we are left with e power xyz into xz. Here we are left with e xyz into x. We can take e xyz common, giving us finally xy x square yz plus x. Now differentiate partially 2 with respect to x. This is 2 dou cube u by dou x dou y dou z which is the required thing, which we can write as right. Now we will apply the product rule again. X y z will be remain as dou by dou z x square y z plus x, right? Now here x square y z plus x dou by dou x into e x y z. In the next step, e x y z, this will 2x y z plus 1. It will be x square y z plus x e power x y z into y z. What we are going to get from this is taking e x y z common, left with 2 xyz plus 1, plus here yz will multiply, we will have x square y square z square plus xyz, giving us finally e xyz into 3xyz plus 1 plus x square y square z square, which is the required proof as mentioned in the given above. So in this way you have to proceed the question. Now let's move on to the next question of second order higher derivative. So the next question which we are going to come across is this: if a square plus b square y square equals to c square z square, where a, b, c are constant, prove that 1 by a square dou square z by dou x square plus 1 by b square dou square z by dou y square equals to 1 by c square z. Now, do we know our standard main function, which is z, as here? No, it is in some random form. We have to get it separately. What we are going to do? First we will write this equation. After this we are going to get z square, which will be what? A square x square b square y square the whole by c square. We are going to move the square that side, which will give me a square x square plus b square y square the whole under root 1 by c plus minus. Now you can either take z minus 1 by c or z plus 1 by c, both are correct. I am going to take z 1 by c under root a square x square plus b square y square for my proof. You can take negative 1 also, both are correct. What we are going to do? Partially differentiate z with respect to x. What we are going to get? What we are going to get? Dou z by dou x. It will be 1 by 2 under root. C will be as it is 2 a square x square plus b square y square, right? Here if I partially differentiate x, it will be 2 a square x, which will finally simplify to a square x c under root a square x square plus b square y square. This is our required thing. Now what we are going to do? This I will call as 1. I will differentiate it this again. Partially differentiate z with respect to what? X. Again differentiate 1 partially differentiate 1 with respect to x. So we are going to differentiate it partially again with respect to x, which will give me dou square z by dou x square, which is nothing but dou by dou x into dou z by dou x, which now I will apply the quotient rule. First thing, I will move the constant outside so that I don't make any mistake. The moment it will square, I will be left with a square x square plus b square y square. First thing, this will be as it is here. Dou square by dou x, it will be x, minus x will be here dou by dou x of what? Under root a square x square b square y square, right? Now in the next step, a square c will be as it is, the denominator will be as it is. Here this will be y square. Here x 2 under root a square x square plus b square y square. This thing here, it will be 2ax square, as it was here earlier where we did that. Here 2a square x, since here our x was x. Now we are going to solve it in the next page, which will be, here we have a square c. Let me draw a line. We have a square x square b square y square. After this, a square x square b square y square. Here 2 will cancel out. We are left with this thing, and sorry, we are going to multiply this and this, which will become similar to this, and here under root a square x square plus b square y square will be left. Okay, listen, this under root when multiplied with this, we will be left with a square x square plus b square y square. This 2 will cancel out. Here we will be left with ax square. Now what we are going to do, if I open this, since it is not under root, this will cancel out with this. This will be a square. This will cancel out with this. I will have finally a square by c, a square x square b square y square minus a square x square, the whole by a square x square b square y square under root a square x square b square y square. So we are left with a square c b square y square, the whole by a square x square b square y square, a square x square b square y square. Now you know this thing, that this thing is equal to c square z square. This thing is equal to under root thing is equal to cz, and this thing is equal to c square z square. So we are going to substitute that value and see what we are getting. If I substitute that, I have b square y square here, one thing. If I substitute here this thing, I will be left with, this will become c square z square, this will become cz, right? So we are getting something like, this, which is a square b square y square c power 4 into z cube, right? So this was what finally dou square x by dou z by dou x square. Now we are not going to solve for y, we are going to say similarly dou square z by dou y square will be what? A b square, here we are getting y, so we will get x square, and it will be c power z cube. Now what we wanted to prove, so 1 by a square into d square x, you have to write it once, equals to 1 by a square. Substitute this value, a square b square y square by c raised to 4 z cube. This will be what? A b square x square c raised to 4 z cube. A will cancel out. We are left with a square, a square, it will be a square. Here a square will cancel out, here b square will cancel out. We are left with a square, y square, b square, sorry, x square, a square, b square, y square, x square, a square, with base same as z cube. Now you know that a square, x square, b square, y square is c square, z square. So we are going to write here c square, z square, the whole by c raised to 4z cube, which will cancel out this, giving me finally c square z, 1 by c square z. So we have proved the given result also. So we are done with these sessions, okay, with these 3 questions. In the next session we are going to continue with some more problems, and this second order and higher order derivative is going to be the most lengthy part of the chapter. Okay, now let's end the session. Thank you for watching the lecture. Hope you have understood each and every step, and don't forget to practice the problems on your own self so that you can get a good score in your examination. Thank you.